Good afternoon, class. Today we're going to continue our notes on the atmosphere. The I can statement that we're focusing on currently is explain how currents in the atmosphere form. Okay, so we have been building up to this topic. We need to understand what wind is. So wind is the horizontal movement of air from an area of high pressure to an area of lower pressure. So if you recall, we did 3 lab type activities a week or 2 ago. One being the simulated vacuum where kids were in a bag. We also did the bottled candle lab, and we also did crush the can. And all of those showed how higher pressure always wants to move to lower pressure, and that's why each one of those labs something occurred. You got crushed in the bag, the can got crushed, or the water was pushed into the test tube. So that is the same thing that we're studying here. Wind is the horizontal movement of air, and it's due to differing air pressures in the air, and high pressure wanting to move to lower pressure. So wind can be measured in 2 ways, or described in 2 ways. One is direction and one is speed. Tool called a wind vane. You guys are familiar with it. Here's a picture of one that some of you may have seen before. A natural wind vane, one more that you might see out and around the town, would be a flag. It is just a tool that shows the direction that the wind is blowing from and to. So the anemometer is also a tool that measures wind speed. So oftentimes when you're listening to the news and they're giving a weather forecast, they might mention the wind speeds. I know in the past couple weeks we've had higher wind speeds, and so you've probably seen those on the forecast lately. So one thing that you need to add to your notes is this part right here, that not only are the difference in an air pressure caused by the time difference that it takes water and land to heat up and then also cool down, it also is due to uneven heating of the Earth's surface. So when we talk about local winds, these are mainly caused by the time differences that it takes soil and liquids, or solids and liquids, to heat and cool. When we talk about global winds, that is on a larger scale, so wind on a larger scale, we are talking more about it's due to the uneven heating of the Earth's surface that causes the differences in air pressure. So here's just kind of a little diagram that talks about wind speed, and you have a question on your notes asking if you're driving down the road. I find this helpful. Sometimes I'll be like, Jesus, when are my tires messed up? Or is the wind really blowing? Like, what's causing my car to pull or be pushed in a certain direction? And so I'll look at a flag. So how fast would the wind have to be blowing in order for a flag to stand straight out? And the answer is 25 miles per hour. So it could be going faster than that, but it's at least got to be going about 25 miles per hour in order for a flag to stand straight out. All right, so local winds, that's our focus for these notes. We'll do another set of notes on the global winds. I think from the 2 different names, local and global, you can tell that local would be winds that only cover short distances. And like we just said on the last slide, these are caused mainly due to the unequal heating and cooling down of land and water. Because those are the 2 types of surfaces on the Earth, that's where your differences are going to come in as far as temperature. And when the global winds are really strong, the local winds aren't an effect to us. They don't cause anything. We don't notice them because we've got global winds. However, when the global winds are weak, then we can more notice the local winds. 2 types of local winds that we're going to be focused on are land breezes and sea breezes. So let's get into the first one. You have kind of like a process chart that you're going to fill in, and this chart shows you how sea breezes can occur during the day. Make sure that you know that sea breezes occur during the day, and land breezes are going to be the ones that occur during the night. There's reason behind this. You also need to know where the sea breezes are moving from and to. They're named sea breezes because that is where the wind starts and it moves toward land. So I remember the name of the breeze is going to be where the wind starts. That would mean that's where the higher pressure air is. So let's get started. During the day, the land heats up faster than the water. We demonstrated this with the sand and water on the overhead. You guys noticed that the sand representing the land of Earth heated up much quicker than the water. So because of that, the air above the land is going to also receive that heat from the land faster. And so therefore the air over the water will be cooler, the air over the land will be warmer. So then we automatically have a pressure difference in those air samples. Because there is higher temperature over the land, lower air pressure is going to be there. And because there is lower temperatures over the water, there will be higher air pressure there. So higher pressure wants to move to lower pressure, and that is why during the day we get a sea breeze often coming from the ocean towards the land. All right, so now you have a spot on your paper where I would like you to draw a diagram. It doesn't have to look exactly like mine, but some key things that you should have would be that you have an ocean area and that you have a land area. Both of those need to be titled and drawn in. And you also have a nice little sun in your diagram showing that it is daytime. I would like to see your convection current being drawn in and where the high and the low pressure is. So you want to make sure that you have those things in your drawing. Now, land breezes. I'm not going to break this up separately because it's basically the opposite of a sea breeze. Land breezes occur during the nighttime. They move from the land to the sea. During the night, the land cools more quickly. So we learned that also from the sand and water demonstration the other day. The water cooled off not very fast. The land cooled off very quickly. So what happens then is the air over the land will cool off more quickly and the air over the water stays warmer during the night. So now we have the lower pressure over the water instead of over the land. That is why higher pressure over the land is going to move to the lower pressure over the water. Again, things that I want you to include in this diagram would be the ocean, the land. You need to have a moon up there. Draw any phase of the moon that you would like. And then you also need to show your convection current direction as well as where your high and your low pressure air is. So I hope this is all making sense to you, and I'll be checking your notes.